Hello, everyone. I am back. It has been a while, and I'm happy to be back to show you some of the progress I'm doing. Let's get started and show you what I've been working on. So you remember we're dealing with trying to open a secret door into a mountain, and so I thought I would just show you this little snippet here, and that's all it does for now. Whenever I cross the x equals 300 plane, it opens up or it frees up the rows in front of me for just one layer of this block of blocks. And then when I come back, it puts everything back together as if the door had closed. So I want to go through the code that I wrote to make that happen, and then we're going to make the code a little better, and then we're going to finish this tunnel, this door thing, and you're going to be able to reuse that in your own code. So let's go check out the code. All right, so you can see the code in this window on the right here. It's very similar to previous. Well, it's not that similar, but the building blocks are there. You can see at the top I'm importing the Minecraft library and creating the Minecraft object that we're going to use. And then I have two little functions over here that basically create the big block of blocks that I have, and another one that removes it. So the Minecraft library has this function called setBlocks, which allows me to create a 3D block that goes from this XYZ coordinate in space all the way to this XYZ coordinate, and filling it up with block number 1, which happens to be cobblestone. And I have this function here that does the exact same thing but replaces the cobblestone with block 0, and block 0 is air, so it kind of removes all the blocks. So when my program starts, it creates these two functions without calling them. And then I call the clear block function to make sure there's nothing in the way. And then we go into this infinite loop, and if you remember, this infinite loop is kind of like our game loop. And then we get the player position, and then we see where the player is, and when the player crosses the x equal 300 plane, then we do something. And if the player is not beyond the x equal 300 plane, then we simply put the big block back. Reset the whole thing, put the giant block back, and it's as if nothing ever happened. So what happens when we do cross that 300 plane? Well, you saw all the rows disappearing one at a time. And I coded this in a way that's very, very explicit. Let's do this one line, and then 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 this one line. So that's not the ideal way to do it, but this way you can at least see what's going on. So the first thing I do is, once again, we're going to remove the first row of blocks. So that big block starts at this coordinate. You remember this is the same as this one, except we're starting at the top, so y equals 74. So x 307, y 74, z 357. So let's take a look in the game and see which block this is. And then we'll take a look in the game and see which block this is. So let's look at block positions here. So right now I'm looking at block 307, 74, 357. This is block 307, 74, 358. So the z coordinate is increasing as I move all the way to 307, 74, 362. So that's what the code was doing to remove that first line. It's removing all the blocks from 307, 74, 357 to 307, 74, 362. And so I put in all those coordinates in my setBlocks function, put in a 0, and the line disappears. And when I created the block, the initial big block of blocks, it's going from 307, 69, 357, all the way to this one over here, 310, 74, 362. So that is how I determine which coordinates I need to add or remove blocks. I just go in the game and look it up. It's like, all right, I'm going to go from this block all the way to this block. Okay, so now that you saw in the game which line this is trying to remove, then now we can remove the next line. But before we remove the next line, we need to tell the program to pause for a little bit. So there's this time function, and I had to import time up there at the top. The time function, the time object has a sleep function, and the sleep function you pass in a parameter to tell the program how long do you want the program to pause or sleep. And so in this case, the program is going to sleep for half a second. So the parameter you pass in is in seconds. And if I don't have any of those sleeps, it feels like all the lines are going to be removed all at once. So let's see. Let's try that, right? Let's see if I can do a 0. And this is what I mean when I say this is not the most efficient way to program, because I want to change all the sleeps to zeros, and this is just annoying to do. Okay, so let's go take a look what happens when I do that. So if the time is 0, it means it's not going to waste any time. The program is not going to sleep at all. It's not going to pause. It's just going to remove all those lines one at a time, but in very quick succession. So quick, in fact, that it looks like the entire portion of the wall disappears all at the same time. That's because the program runs really, really fast. It's removing all of those lines so quickly that to the naked eye, it looks like they're all gone at the exact same time, which is not true. It's actually removing them one at a time, but it's going very fast. So that's why we need the sleeping statements in there, the sleep calls, to slow it down a bit. So let's go slow it down a bit. All right, so it should be slowed down back to half a second. And now there's a half a second delay between each line being removed. And that's basically how you create an animation. And we can control how fast we want this to go. Now it's going to be very slow. 1 second in between each block. All right, so all the sleeps are at 0 and it was going really fast. But changing all those sleeps is really annoying. Every time I want to change the pause between for the animation to speed up or slow down the animation, I have to go on each one of these lines and change the variable. And now we're going to get into a little bit of programming stuff. Instead, I'm going to create a variable, and I'm going to put it here at the top for now. I'll call it ST. ST stands for sleepy time. And I'm going to set it to 0.5. And here, instead of 0, I'm going to put ST. And ST stands for 0.5. Here we go. So if I rerun this program, now the animation should take 0.5 seconds. The sleep time should be 0.5 seconds in between removing each row. So that's a good first step to put the sleep time there. And a next step would be, I don't know, let's you notice here that the 307 is the same everywhere, right? Because we're modifying a wall that's on the x-plane. So it's 307, 307, 307, 307 everywhere. So let's change it to x equals 307. And then we can change this to x everywhere. There we go. And the z changes, and then the y changes, but the y remains the same. We can take this now and put that into a function, I guess. So let's create a function. And the function is going to be, I don't know, scroll down wall. And then we're going to pass in an X parameter. So which wall are we trying to scroll down? And it's going to be whichever parameter we pass in is going to be that wall that we're doing. And then I'm going to take all of this, copy, come here, paste it, align everything because this is Python. And everything has to be aligned. All right, so now my X here is going to be the X everywhere. I don't need this. Well, I guess I can keep it. And then here, instead of doing that manually, I'm going to change this and call my function scroll down wall. And I'm going to pass in 307 as the wall I want to scroll down. And I'm going to add one more sleep at the end there. So let's add one more sleep. We don't need this one over here anymore. Let's save this. Let's run it. And let's go check out what it looks like. So let me just bring the Minecraft window here in the foreground. It's going to be easier than switching over. The same thing happens. Exact same thing. So now here's the difference. Now, because I have this function, I can do something way more interesting. I can go back in the code and I can add another call to this function. And now I'm going to do 308. All right, run this, go back in the game, and let's see what happens. So the first one is going down, and then the second one is starting to go down as well. How much code did we have to write to make the second one go down? Just one line. So that was easy. And then I can add a third line and a fourth line. And I could create another function that opens up the wall in a different way and combine them together. So when we go back and look at the code I created initially, I had all my variables set up. I had a reset function to close a door. I had a function to remove a row, a function to add a row, a function to remove a column, and then I could slide a wall up, a row up, and I could slide an entire plane up or slide it down, and I could close. I could do a couple of things. I also had a function to split open a plane. Remember, the wall was opening from the middle and scrolling to the sides. And then I had the circle of lights, which was basically creating a couple of 89 blocks, which are the glowstone blocks. I had a code to create a room, which was basically emptying out a square inside a mountain. I had my open door, which would basically call each of these one at a time. And then I had my game loop at the bottom, which monitored the player position, would either open a door or reset it. So this is basically the gist of it. And from here on out, I feel like you have the tools you need to be able to experiment with opening secret doors on your own. And I wish you good luck.